In this video, I'll be introducing you to data sciences and artificial intelligence. You might have heard of different words like data sciences, data analytics, big data, deep learning, machine learning. And if you're like me that was initially confused by these different terms, just sit back and relax, because at the end of this video, you understand these different terms and how they all relate. Hi guys, welcome back to my channel. My name is Promise. In case you missed my introduction video, I'll be putting a link to that at the end of this video so that you could watch and understand what this channel is all about and know me better. So let's dive right into the business of today. It all starts with artificial intelligence, which simply means human intelligence exhibited by machines. AI uses computers and machines to mimic the problem-solving capability or decision-making capability of humans, just in the way a human mind would work. There are two types of AI. We have narrow AI and general AI. Narrow AI is good at one task and can perform one task very well. On the other hand, the general AI can do multiple things. It has multiple abilities or capabilities. Have you heard of Jack of all trades and master of none? That should come to mind. A subset of artificial intelligence is machine learning. Is training your machines to do things without being programmed to do so. So your machines learn from your data. You just give it your data, looks for trend, and just learns from the history of the data. We have different types of machine learning. We have supervised machine learning, we have unsupervised, we have reinforcement learning. So I'll be going into details in subsequent slides. A subset of machine learning is deep learning. It is a category of machine learning that emphasizes training the computers or the machine about the basic instincts of a human brain. So the way a human works with neurons, connecting, following certain neurons to make decisions. On the other end is data sciences, like the name implies, the science of data, analyzing data, looking for trends, just getting to know your data on its own. I'm very sure a lot of us are already doing data sciences. If you're dealing with data and you're analyzing data, be it seismic data, well data, you're already doing data science, trust me. So when you try to, data science just encompass anything you do to understand your data better and to make predictions or assessment of data you have. We have data analytics as a subset of data sciences, just examining your data to look for trends, patterns, history, and make meaningful conclusions from them. We also have big data. Big data, these are data that are too large or complex to be analyzed using our traditional data processing softwares. We also have big data analytics. So I'll be explaining what big data means in a short while. So if you look at this diagram very well, you see that there are crosses and intersections between these different fields. So as a data scientist, you should understand basic machine learning. You should know what big data is. You should know artificial intelligence. On the other hand, as a machine learning engineer, you should also understand data sciences for you to understand your data. So they all go hand in hand, even though we have, for example, we have extreme data scientists, we have extreme machine learning engineers, but there are some grounds in between where you could play around both of these. Something you should also realize at the core of everything we've been talking about so far is data. So what is data? Data is information. Any information is that you have an information. It could be like number of people watching this video right now or number of likes I have. Those are data. According to the Cambridge Dictionary, data is information, especially facts or numbers, collected to be examined and considered and used to help decision making or information in an electronic form that can be stored and used by a computer. So simply put, data is information that is collected for use, so it has to be useful. So there are different types of data. So it depends depending on the field you work in or the industry you work in. So we have transport data, we have scientific data, we have cultural data, we have financial data, we have medical data, we have meteorological data, so it depends on whatever field you have. So we have different kind of data that suits your needs. So there are two basic types of data. We have structured data and we have the unstructured data. Structured data comprises of clearly defined data types. So it's well sorted. It normally comes in rows and columns. So with structured data, you can easily perform analysis on. On the other hand, we have unstructured data. So everything else that's different from structured data that is not in rows and columns. They are mixture of different types of data. So you could have video data, you have audio data, you could have tables, you have rows and columns. So you have different mix. So unlike the picture on your screen shows, you can see it's just everywhere. So the disadvantage of this data is you can't easily carry out analysis on it on an unstructured data. So you have to clean, it has to go through the process of cleaning, processing in order to be fit to perform analysis on. They both have the advantage and disadvantages. So but that's too much for us to cover now. We'll cover those in subsequent videos. There are two forms of data. We have the traditional data, so it's in megabyte, gigabyte, can fit into your computing device like your phone or your computer. And we have the big data, it's in petabytes. Most of the time, I don't think any of our laptops or computers have enough space to contain petabytes of data. So with structured data, it is stored in databases and you can easily analyze and manage your data from your computer. For big data, it's data in petabyte, like I said, and a big data is characterized by 5 V's. We have volume. So for a data set to be big, it has to be voluminous. And some of this data come from telecommunication companies, weather, e-stations, shares market. So data that is very big, and for it to be big, it has to be large. The second V is variety. This refers to the type and nature of the data, where the data is coming from, and most of the time it comes in different scales and sizes. For example, in the oil and gas industry, if you're getting data like core data, wireline data, seismic, everything together, those are varieties of sources, so we could call that big data. The third V is velocity. This looks at the speed at which this data is acquired. In the energy industry, we could look at logging while drilling, real-time data collected like production data while you're producing your assets. So those data you collect, so they are coming in real time and in a very high velocity, or logging while drilling data. Our fourth V is veracity. How reliable is your data source? How trustworthy is the data? What are the uncertainties associated with this data, and how is this understood? And our final V is value. How valuable is your data? You don't want to waste space on your storage device storing data sets that are not valuable. So the data has to be valuable. So now let's just go into data sciences. Data science is the science of data, studying your data, studying the past, the history of the data, analyze the data, and see if you could make predictions from the data. So it combines different domain knowledge. You need machine learning, you need modeling, you should have good understanding of statistics, programming, and understand databases. There are 4 different phases in data analytics, characterized by value and the complexity of the phase. So we have descriptive analysis, understanding what has happened with the data, what processes have the data gone through, how was the data acquired or processed. We have diagnostic analysis, understand, okay, after having understood what happened to the data, you want to understand why did this thing happen to the data. And we have predictive analysis, understanding, so if I've understood what happened and why it happened, how can I predict trends given the data? How can I predict what will happen next given the data trend? Then we have prescriptive analysis. After you haven't understood what happened, why it happened, and you have made your prediction, so how can I influence what will happen? How can I influence the outcome? So if my prediction is positive, so how can I influence that to maybe happen faster or make happen better? Or if it's a negative, how can I prevent this prediction from happening? That's prescriptive analysis. Let's talk about machine learning. Machine learning is training your machines to perform tasks without being programmed to do so. A traditional programmer would give your computer, your machine, let's use mathematical terms, for example, X, you give it a function for it to get Y. So your functions could be X power 2 it will give equals to y. So whenever I give x, if I give x equals to 2, my y will be 4. If I give x equals to 6, my y will be 36. So but for machine learning, you don't do that. You give your machine the problem and the solution. It looks at it, comes up with functions in form of model. Subsequently, these problems can be fed into that model created by the machine to get solutions. There are two types of machine learning. We have supervised machine learning and unsupervised. For supervised, like what I've been talking about so far, is supervised. You have your desired outcome, you give the machine looks for a function, outputs a model and gets your result. There are two types of supervised learning. We have classification and regression. For classification, you are predicting classes, is it this or that. You have binary classification where you are just predicting only two things, and we have multi-class classification where you are predicting more than two things. We have regression. You are predicting a continuous variable in form of numbers. So if I'm predicting the price of a house, for example, or the price of a stock, I want to predict water saturation, permeability, or porosity. Those are all regression problems. For unsupervised, unlike the supervised, we don't have labels. You just have only the data. So the machine looks at the data, outputs a model in forms of different clusters. You just analyze these different clusters to make meanings from them. I hope you've enjoyed this video so far. Let me know what you've learned in the comment section. If you have any question, please put them in the comment section. And if you have any question, if you have anything you want me to talk about, any topic you want me to explain, so just put that in the comment section. You could reach me on my social media platform. I'm on LinkedIn, I'm on Instagram, Twitter, or Facebook. I just type in Promise AK. I will also put a link in the description box for you to follow me. In my next video, I'll be talking about data sciences in the energy industry, the different parts of the industry, like especially the upstream industry, how data scientists can help improve different operations. Thank you for watching this video. Do have a lovely day.